For our first couple of problems, it says to sketch the graphs of the three functions by hand on the same rectangular coordinate system. Verify your results with a graphing utility. So I'm not going to take the time to graph these on my calculator, but I will graph them in the same coordinate system, and I wrote them down just so that I'm not flipping back and forth. So using this graph paper that I already have, the first one is f of x equals x minus 2 squared. So you're going to be shifting the x squared graph to the right 2 units. So our parent function is y equals x squared. Remember to keep that shape in mind. So instead of 0, 0, the graph is going to start at 2, 0. And then I have this x squared shape memorized, or I can just say, plus or minus 1, 1 from the vertex, plus or minus 2, 4. So there, and hop it over. And then you can go over 3, up 9 on either side. So here is x minus 2 squared. I would suggest color coordinating these on your own homework, just so you can tell which is which. It's hard when they're all on the same grid, or use different graphs. G of x is left to up to, again, from the original x squared. So the vertex will be at negative 2, 2. And then other than that, it's still an x squared graph. So from the vertex, I'm doing my plus or minus 1, 1, plus or minus 2, 4, over 3, up 9. It's just off the grid. I'm just going to plot it just because. So here's g of x. Or you could also label, this is f of x. This one's g of x. And I'm doing h of x in green. So h of x has this x-axis reflection, which means that every x value, the y values become negative. And then we're going to go, after we do that, after we figure out those points, right to down 1. I usually do need to do this in stages, so I'm going to write these out. They're not hard to write out, the x-axis reflection part. So 0, 0, plus or minus 1, negative 1, plus or minus 2, negative 4, plus or minus 3, negative 9, and then all of those will go right to down 1. So 0, 0 is going to go right to down 1. And then, oh, what happened to that? Right 2, down 1. And then after, I don't know where that point keeps going. After that, there it goes. After that, from the vertex, you can either do from the vertex plus or minus 1, negative 1, or you can follow your points here and then shift them right 2 and down 1. So from my vertex, over 2, down 4 on both sides. From the vertex, over 3, down 8. So 3, 6, 9. I said down 8. I meant down 9. So here is h of x. Okay, number 18 is our next one. So we've got our square root function. The first graph is just the original f of x equals square root of x function. So that's easy. 0, 0, 1, 1. Square root of 4 is 2. Square root of 9 is 3. Okay, that's going to bother me that that's not going through there. So a little bit better, little better. G of x should be the same x coordinates as f of x, but every y coordinate gets multiplied by 1/2. That's a dilation by a factor of 1/2. So 0, 0 remains the same. 1, 1/2, 4, 1, 9, 1 1/2. So I just took half of every y value that was on there. I should be labeling those. That's f. That's g. And h has an x-axis reflection, and then everything's going to go right 4 units. So I'm going to start with that beginning point, shift it to the right 4 units because it's unaffected by the x-axis reflection. So 1, 2, 3, 4. So the starting point, I'm going to call it, is here. And then a negative square root graph looks like that, right? So I'm just going to say, instead of square root of 1 is 1, it'll be 1 and then negative square root of 1. From here, go 1, 2, 3, 4, negative 2. And the last point's going to be off the grid. What we're trying to avoid with this is, you can get any graph by just plugging in a bunch of points. It's just that that's time consuming, and you also want to be able to understand the relationship to how all of these numbers actually affect the graph and what's happening visually. But it's mostly for efficiency too. Okay, 20 has the original parent function for f of x. So I am going to draw in the asymptotes because I don't want to make the branches of my graph too wide or too narrow. So x equals 0, y equals 0. I think I'll write that down. There's a point at 1, 1 with a branch that just kind of, I'm not going to make them too big, but just kind of has a smooth curve that fits into the corner without crossing through either asymptote. Negative 1, negative 1, same shape of that branch. G of x, so that was f. G of x is down 4. Now, if you shift a vertical asymptote down, it stays the same. So you're still at x equals 0. But y equals 0 will be down to y equals negative 4. So I'm going to draw that in to guide me. 1, 2, 3, 4. So here's G of x's horizontal asymptote. And that just takes the original points. Negative 1 is now down 4 units. 1, 1 is down 4 units. And you can still kind of fit it into the corners. This is the one that looks the most confusing, that they're all on the same graph. So if you're doing this in pencil, again, just label things. Okay, and then h of x, the x plus 3 is inside the function, so that's left 3. The minus 1 is at the end, that's down 1. Shifting left or right will shift the vertical asymptote left or right, so it's going to be x equals negative 3. And the horizontal asymptote is going to be y equals negative 1. So I'm going to draw in the vertical asymptote and the horizontal. Even with my colors, I'm like, my eyes are like struggling here to follow all this. Instead of shifting points around, you can also just say, kind of find the epicenter, we'll say, of your rational function here. Plot a point in either little corner there. But that is taking the 1, 1 point and shifting it correctly, and taking the negative 1 point and shifting it correctly as well. Oops, that was H. Okay. For 22, you can see they've given you this graph. I didn't copy the graph for some reason on my page. Actually, I'm going to do that right now. I want to have just the shape of the graph. I did write my coordinates on my page, so that might be helpful. I'm just going to try to post. There we go. Just to have this, I don't know, in case we need it. Here's the originals. We're going to see what's happening to it. So here are the original points written out. I'm going to graph A and B on this graph and C and D on the second graph. So starting with A, this should be a shift down 1. So I'm just going to take each of these original points and shift them all down 1. So negative 2, 3. Down 1, right? Yeah, so 0, 2. 1, negative 1. 3, negative 2. Now, my grid is not in the exact same scale as the original one, but we are holding the same shape, right? And then let's do B on the same graph. This is the graph, but shift everything up 3. So negative 2, 4 will be at negative 2, 7. 0, 6. 1, 3. And 3, 2. So graphs A and B should hold the same shape. They're just vertical translations of each other. C and D are horizontal translations. So C is going to be left 2. So I'm taking each of these, still these original coordinates, and moving left 2. So we're going to start at -4, 4, -2, 3. And I'm just subtracting 2 from everything. My brain is just like a little fried. So -1, 0, and then 1, -1. Again, it should hold the same shape. Like, look at your red graph here. All the points are the same slopes and distances from each other. It's just shifted differently. And then this is right 1. So instead of -2, 4, it's going to be -1, 4. And it's going to be 1, 3, 2, 0, and 4, -1. And then there's an E and an F. So E has an x-axis reflection. So I'm going to write the points for E out here. Every y value gets the opposite sign that it had. And then after that, we're going to go right 2. So it probably would be helpful to write these out, at least for me. So I'm going to show myself changing the y values to be the opposite sign of what they were. And the x values stayed the same. So I'm just going to hover my pencil over -2, -4, and then I'm going to shift to the right 2. So the first point for E is 0, -4. And then I'm going to hover over 0, -3, but go right 2. 1, 0, right 2. 3, 1, right 2. Remember, this should look like an x-axis reflection. So take the original, which is here, flip it upside down, check, and then shift it to the right 2 units. And for F, no translations vertically or horizontally, but we do have an x-axis reflection, or I'm sorry, a y-axis reflection, where every x value gets multiplied by -1. Y values remain the same. So if I look at my originals, I see them right there. I'm looking at these. So now change the x coordinate and leave the y coordinate the same. 2, 4, 0, 3, -1, 0, -3, -1. No shifting required, just plot these points. And then connect them. So this function has kind of a weird shape. It's not an odd function, it's neither, but it has that thing where sort of the x-axis and the y-axis reflections look similar on this. So that's just kind of something to note, I think. And let's see. Oh, and then no shifting. So that was the final thing. So from our original, if you take a look at our original, this has been flipped sideways. Okay, and then, oh, there's a G and an H. Okay, so G is going to be, keep the x values the same. We have a vertical dilation by a factor of 1/2. So every y value gets multiplied by 1/2. I need my little, let me see if I can scoop this down. Take this with me because I don't have the page in front of me. If you're looking at the page on the computer, I would just split screen it. Okay, so -2, 2, 0, 3 over 2, 1/2, 1, 0, 3, -1/2. No shifting after that, so just plot these points. And remember what this should look like is a vertical shrink by a factor of 1/2. So the points are half as tall as they were. And then for H, the 2 is on the x. So we take every x value and divide it by 2. Leave the y values alone. This is a horizontal dilation. also by a factor of 1/2. So 1 over c in that case. All right, so the x values, going back to these originals, multiply the x values by 1/2. So -1, 4, 0, 3, 1/2, 0, 3/2, -1. This should be a horizontal shrink. So the graph should look narrower once we're finished. So it's just as tall as it was to begin with, but it's more narrow left and right horizontally. Okay, now we're just describing. So 62, I have a little with a little asterisk on this one. So it says you need to write the equation, write a function who has the shape of f of x equals x cubed, and then you're going to shift 6 units to the left, 6 down, and then reflect in the y-axis. So when we are looking at an equation, we do the stretching and reflecting first, and then we shift. But if we're told how to build the equation, we have to do this reflection last, which is unusual for us. So be careful with this. So first thing is left and down. Two things here. We're supposed to write a function, so we need something equals, and you need to make it something other than f of x, because f of x is taken. We're creating something different, so I'm going to call mine g of x. Left and down means g of x is going to be f of x plus, we're going left 6, and then down 6. So g of x is going to be x plus 6 cubed minus 6 so far. And then we reflect in the x-axis. So now reflect in the y-axis. So y-axis reflection is g of negative x. So take your g of x, plug in negative x, leave everything else as it is. Don't distribute a negative through. That's my final thing. So g of x, I know I wrote g of negative x, but it's kind of flawed notation there, but my final g of x is this graph here. And you can check these on a graphing utility. Graph x cubed, graph this equation, and see if it has done all of the things, like could you shift that left, down, and then wherever it is, flop it across the y-axis, and would it land where it is on your screen? Okay, 64. Shape of square root of x, 9 down. So g of x is going to be 9 down, f of x minus 9. And then we're going to reflect x and y-axis. So then we're going to do, like, I guess what it probably should be, my first one I was like, oh, that's bad notation. It should be like, create g of x. G of x is square root of x minus 9. Then create this h of x, which is negative g of negative x. Because you're trying to go reflect across both the x and the y-axis. G of negative x, start there. Puts a negative x in for the x. Distributing a negative out in front here means literally distributing the negative. H of x is negative square root of negative x plus 9. Those are confusing. They take some practice. We'll definitely be working on this for another couple of days. And our last couple of questions we need our graphing calculator for. So let's read through this question. The numbers n in thousands of new single-family houses sold in the southern United States from 2010 to 2017 can be expressed by ordered pairs in the form T, n of t. T equals 10 is 2010. Here's our model. Okay, so we're given these ordered pairs. Part A says describe the transformation before we graph anything. Describe the transformation of the parent function t squared. So take a look at n of t. We've got a n of t is a vertical dilation. by a factor of 1.5. It's vertical because the 1.5 is out in front. And then after that, it is I'm not going to say horizontal translation. I'm just going to say shift right 4.8 and up 123. Okay, use a graphing utility to graph the model and the data in the same viewing window. So a reminder on how to do this. This is what we did with linear regression. Go to y equals and clear out any old equations. Press second y equals to set up your stat plot. So choose plot 1, turn it on, type should be scatter plot. You might have changed this from the last thing that we did, but the x list is L1, the y list is L2. So to change that, I press second 2. And then stat edit. I've got stuff to clear out, so I go up to the heading of each list and press clear, enter. Clear, enter. Clear, enter. Type in what I have. So we have 10. It's going sideways. That's kind of annoying. It doesn't matter what order you type it in. But you're going 10 to 17. So 10 to 17. And then just make sure that you're typing in the correct coordinates together. You don't want to skip around. Okay, so get everything typed in. Type in the model. We're not doing any sort of regression here. They gave us a model, remember? So go to y equals and type in the model. It's 1.5 parentheses x minus 4.8 parentheses squared plus 123. I'm still going to zoom stat because remember, zoom stat fits the window to see all the scatter plot points, and our model should fit closely to those points ideally. So zoom stat is option 9. So you press 9. There it is. So I've got a screenshot here. I put some notes here on the key. You can pause this if you need to, or go back and watch how I did it. And then part C says, rewrite the function so that t equals 0 represents 2010. Explain how you obtained your answer. Okay, so think about this. Originally, we had this ordered pair, 10, 173. And the new one, so 2010 was t equals 10. What they want this to be is 0, 173. T equals 0 represents what happened in 2010. So what we need to do to our model to shift it correctly, this has been shifted left. This original point got shifted left 10 units. That means that we need to create n of t plus 10 to get a shift of left 10 units. So that's just taking n of t, plugging in t plus 10 in for that t right there, minus 4.8 squared plus 123. Now I would clean this up. 10 minus 4.8. So 10 minus 4 is 6. 6 minus 0.8 is 5.2. So 5t plus 5.2 squared plus 123. So this would be my new n of t model. I'm just going to call it n of t like new or something. Okay, 69 to 72. F of x has an x-intercept at 2 and negative 3. Find the new x-intercept if possible. So that seems kind of weird, if possible. Let's just go through each problem and see what happens. So if y is now f of negative x, I just wrote down the original two x-intercepts as ordered pairs. So we'd have an x and a y to work with. This means that our new xy will be negative xy. So negative 2, 0, and positive 3, 0. And so the new x-intercepts, the old x-intercepts are, here are the new versions of those. So that's really all that we're doing here. For 70, if we have 2 f of x, that's going to change every point so that it's x 2y. But that's still going to be 2, 0, and negative 3, 0. So if those were the only 2 x-intercepts to begin with, they're still the only 2 x-intercepts. Now we have a vertical shift of up 2. So we don't normally write the math for this, but what that's going to do to each y value is add 2 units. So the point that was at 2, 0 is now at 2, 2. And the point that was at negative 3, 0 is at negative 3, 2. So these are no longer x-intercepts because x-intercepts, remember, are like an x-coordinate when y is 0. And we don't know anything about the rest of the points. I don't know what kind of graph this is. So this little note just says, since we don't know anything about the rest of the graph, we don't know what the x-intercepts are or if there are any. So this is why it says, if it's possible, find the new ones. It's not possible to find the new x-intercepts given the information we have. All right, and then this next one, x minus 3, this is shifting to the right 3 units. Now, again, we don't normally write the math behind this, but if you're shifting something to the right, even though this says x minus 3, you're going to be adding 3 to every x value because that would shift things to the right. So the point that was at 2, 0 is at 5, 0. And the point that was at negative 3, 0 is at 0, 0. And because those y coordinates are 0, those are the new x-intercepts. For this last section, we're finding domain. This is just review because domain can be a pretty tricky concept and we'll be thinking about it a lot this year. So I just wanted to go back to do domain for some of these problems. F of x is rational, so the denominator can't equal 0. That means that x can't equal 9. So the domain is anything but 9. Negative infinity to 9, 9 to infinity. 82 is a rational function, but it also has a square root. So we've got to make sure that the square root expression remains positive, and we've got to make sure that the denominator never equals 0. And then we'll merge these if we need to. So x needs to remain greater than or equal to 5, but x can't equal 7. So the domain is starting at 5 up to 7, but not including, and then picking up at 7 and going out to infinity. 83, we had a couple of graphs, or we had a graph that was like the square root of 16 minus x squared. So remember this graph, or be able to sketch this graph. If it's 100 minus x squared, that's a half circle with a radius of 10. And so that should help you with your domain and range. Well, we're not doing range, but domain is negative 10 to 10. We haven't talked about how to solve quadratic inequalities, but we are solving the inequality 100 minus x squared stays greater than or equal to 0. We will get to quadratic inequalities, we're just not there yet. Excuse me. 84 is another difference of squares, but important difference, it's under an odd root instead of the even square root. Even roots, we can only even root a positive number because a number times itself will give a positive value. Odd roots, you can odd root positives and negatives because when you raise negatives to an odd power, you get negatives out. So 16 minus x squared can be anything. It can be positive, negative, 0. We'll be able to cube root it. So this answer is all real numbers. Okay, that finishes the homework for today. Please come to office hours if you had any questions or ask at the start of class.